Hello, everyone, and welcome back to another action-packed episode of our pre-algebra screencast series. We are on to lesson 7.4, which is percent of change. So, without further delay, some interesting information here. The first motion picture, moving film, if you will, was in 1888, 2.11 seconds, 2 and 11 hundredths of a second. And it cost 36 cents. Now, back then, that might not seem like a lot of money now, but back then you could have lived for a couple of weeks off of 36 cents. So it was a lot of money. I don't know if I would have paid paid that much money for 2 seconds worth of screen time, but it depends on what you value. Anyway, percent of change is our topic. What is percent of change? Basically, it's taking the amount of change that occurs between a period of time and looking how much of a percent it was. So you take what's the change divided by the original amount, and you make a percent out of that. Okay. It can be an increase if the change was positive. It can be a decrease if it was negative. So let's take a look here. We have Ty in his comic book collection. It went from 52 to 61. So that's an increase. I always do increase and decrease first so I don't get confused. What was the change? 52 to 61 was a change of 9. Remember, you must compare to the original. Do not compare to the new amount. 61 is no longer necessary. 9 out of 52 is... I forgot where I put my regular calculator. Grab another one out of here. Every math teacher has like a million calculators, so no shortage of supply. It says round to the nearest tenth, so I got 17.3% increase. So he increased his collection by 17.3%. It's as easy as that. Let's take a look at another example. We're on page 271 now. Find the percent of change from 18 to 24 to 18 points. That is a decrease. It went down. Could be a good thing or a bad thing, depending on what we're talking about. How much did it go down by? It went down by 6. It was a negative 6 change. What did it start as? 24. I can do this one in my head. 6 over 24 is a 25% decrease. Sometimes they're as easy as that. There's no rounding necessary. Now, percent error is very, very similar to percent of change. You're still looking at the difference between two numbers. Instead of comparing it back to the original, you're going to compare it to the actual amount. So, same basic principle here. We have a weight of 8 pounds was the estimate compared to actual weight of 6.4. So that's a difference of 1.6 over the actual now, because you're always going to compare it to what it should have been. How much of a mistake did you make? 1.6 divided by 6.4 is a 25%. In this case, instead of increase, decrease, it's an error. It's always going to be an error. This is a pretty bad error, depending on what this is. Okay, you want your error to be as little as possible. All right, next up, measured length. You thought it was going to be 2.5. It's actually, always looking for that word actual, 2.54. So the difference is 0.04, so not much of a difference. Actual on the bottom. Divide those. And you get 1.6. It's a lot of decimals, but it says round to the 10th. It's 1.5748, blah, blah, blah. You only need the first two decimal places. 57 rounds to 6% error. This lesson is not terribly hard. Whoops, messed my circling up. But take your time. Make sure you understand it. It's the change over the original as a percent. Is it increase, decrease? With error, it's the change, the difference rather, over the actual. And once again, you're looking for a percent. So take your answer. If it's a decimal, times 100. If you just leave it as a fraction, you can take your fraction times 100. Any questions? See me in class, message me on Canvas or email. Do whatever it takes to dominate this lesson. Talk to you soon. Bye.